Hello friends, how are you? I hope you will be all fine. So today's topic is relations, and this is actually there is a chapter in 11th class as well as in 12th class, and the name of the chapter is relation and function. So we will be doing relations of 11th class. This is based on CBSE, and in my next lecture I will be dealing with relations in of 12th class. So now what does this relation imply? We all know the meaning of relation. There is a relation between two people. There is a relation between two objects. Like for example, there is a relation between, suppose there is a son and father. So there is a relation, and similarly wife and husband. So this is also a relation. So similarly in mathematics we have relations, and those relations are between any two objects or two numbers. There are different type of relations in mathematics. For example, there is a number 5. This is greater than 2, or I can write x is greater than y. Similarly, I can write the x is equal to y, or I can write y is equal to x plus 2. So these are different relations between two variables x and y, right? So going further into details of this, what we should know is that what is sets. Now sets is the well collection of objects. We know this from the chapter sets, that sets is a well collection of objects or elements, you can say. So to understand the topic relations, we should know little about sets, and then we will jump to the operation called Cartesian product, and from there we will start with the relations. Now sets is a well collection of objects or elements, as we have told. So now we have read there are some operations in the set also. What operations are there? We have read like operations. We have learned some operations in sets, such as union, intersection, complement, and so on. So there is one more operation which we have left in the chapter sets, which we will be learning now, and that is called Cartesian product. Cartesian product. Now we should first understand what is Cartesian product. Now we will be learning this topic, Cartesian product. Okay, before we deal with Cartesian product, let us try to understand what is ordered pair. What is this? What is ordered pair? Actually, ordered pair consists of two objects or elements in a given fixed order, right? Let me write this definition. An ordered pair consists of two objects or elements in a given fixed order. So for example, suppose we make an example. Suppose let me make, these are suppose two sets, say A and B, and there are elements 1 and 2. Over here there is element A. So if I join this A1 with A, this I get one ordered pair 1 comma A. If I join 2 with A, I get another ordered pair 2 comma A. So these are called the ordered pairs. In ordered pair there are two elements, right, in a fixed order. This, the first one, this is called first element, and this is called second element. Obviously 1 comma A is not same as A comma 1. Why? Because the first element over here is 1, while the first element over here is A. So if the two ordered pairs are same, that means the first element should be equal to the first element and the second element should be equal to the second element. For example, let's take an example. Suppose x comma y is equal to 1 comma 2. That means x is equal to 1 and y is equal to 2. So first element is equal to first element, second element is equal to second element of the two ordered pairs. I hope you got this point. So students, now suppose I take an example. Let me take a small example. Suppose I write 3a minus 2 is equal, comma, b plus 2 is equal to 2a minus 1 comma 7, right? So if the authors want us to find the value of a and b, what we will do, 3a minus 2 is equal to 2a minus 1. So this becomes 3a minus 2a is equal to 2, we are shifting 2 over there, minus 1. So a is equal to 1. And similarly b plus 2 is equal to 7. So b is equal to 7 minus 2, that is b is equal to 5. So this is the meaning of, you can say, ordered pair and how the two ordered pairs are equal. So we have read till now, what we have read is what is ordered pair, and second we have read the equality of ordered pairs. Equality of ordered pairs. Now we come to our main topic, that is Cartesian product. And after Cartesian product, we will start with the term relation, right? So what is Cartesian product? Now suppose I say that there are two non-empty sets A and B. A and B are two non-empty sets. Let's write it over here. Suppose this is A, this is B. Suppose this is 1, this is 2, this is A, this is B. Suppose there are these two sets. Now I want to find the Cartesian product, that is A cross B. Cartesian product is written like this, A cross B. So now we have to, what we have to do, we have to join the first element from A to either A or B. So it can go like this or it can go like this. One can go to A, one can go to B. So the ordered pair can be written as 1 comma A, 1 comma B. Similarly, the 2 can go from 2 to A or 2 to B. So this is 2 comma A, 2 comma B. So these set of all ordered pairs is known as Cartesian product. So what is Cartesian product? Cartesian product is set of all ordered pairs, right? And we can also write it like this. Suppose I write A cross B is X comma Y, such that this column means such that X belongs to A and Y belongs to B. We can depict this mathematically in this way. So suppose again on the above example I want to write B cross A. Now B cross A means all the first elements should be from set B. So it is like this: A comma 1, A comma 2, B comma 1 and B comma 2. So what we are from here, what do we understand? We understand that A cross B is not equal to B cross A, right? Why? Because the first element and the second element has been interchanged. Now we can understand this very well. For example, in our junior classes, what we do, we plot the points on the Cartesian plane, right? Suppose I write 1 comma 2. Now if I want to plot it, let this be 1, this is 1, 2, so the point is over here. This point is 1 comma 2. Now is it same as 2 comma 1? No, because if I plot it over here, so it is 2 and somewhere here it is the point. This is 1, this is 2. So this point is 2 comma 1. So you can very well see that 1 comma 2 in the Cartesian plane is not same as 2 comma 1. Therefore 1 comma 2 is not equal to 2 comma 1, right? So as in the previous we have said that two ordered pair will be equal if the first element is equal to the first element of the another ordered pair and second element is equal to second element. So if all the collections, if we take all the collections of these ordered pair, that is called the Cartesian product. Now question arises, how many elements are there in Cartesian product of two sets? In our previous question we had n, that is number of elements in A is equal to 2 and number of elements in B was also equal to 2, and we found that number of elements in A cross B was equal to 4. See, 1, or over here you can see 1, 2, 3, 4. So these are the 4 elements. How we got it? We got it like this: NA, that is number of elements in A, into number of elements in B. So this becomes a formula to find out the number of elements in the Cartesian product of the two sets. Suppose I say that number of elements in set A is equal to n and number of elements in set B is equal to m, then number of elements in A cross B will be equal to n into m. So n into m are the number of ordered pairs in the Cartesian product A cross B. I hope this is clear. Now suppose there are three sets, say set A, set B and set C. Suppose there are three sets and we want to find the Cartesian product of the three sets. Cartesian product of three sets. How to find it? So A cross B cross C is equal to, suppose I write like this, A comma B comma C, such that A belongs to capital A, B belongs to capital B and C belongs to capital C, right? Or we can write it like this, A cross B cross C is equal to x comma y comma z, such that x belongs to A, y belongs to B and z belongs to C. Yes? Okay. So this is the concept of Cartesian product of the three sets. We can take an example and then we will be more clear. Suppose I say A is equal to, let A is equal to 1 comma 2, B is equal to A comma B and C is equal to, suppose, L comma M, right? And I want to find A cross B cross C. So what is the best method? First you find A cross B and then you cross it with C. Now A cross B is equal to 1 can be attached with A, or 1 can be attached with B, 2 can be attached with A, 2 can be attached with B. This is A cross B. Now A cross B cross C. So what we will do, this 1 comma A can go with L, 1 comma A can go with M, similarly 1 comma B can go with N, L, and 1 comma B can go with M. So let me write all these sets. 1 comma A comma L, 1 comma B comma okay, first let me A वाले finish कर देते हैं. 1 comma A comma M, 1 comma B comma L, 1 comma B comma M, 2 comma A comma L, 2 comma A comma M, 2 comma B comma 1 L, sorry, 2 comma B comma M. So there are 8 number of ordered pairs, right? So N A cross B cross C can be written as NA, number of elements in A, into number of elements B into number of elements in C. In this particular case, it was 2 into 2 into 2, which is equal to 8. It can be different also, means 2 into 3 into 2 like this. So we have taken an example in which there are 2 elements in each set. So till now, we are now clear with the concepts such as ordered pair, then Cartesian product. So this is clear to us. Now we come to the topic called relations, right? Okay. Now our topic starts, that is the relation. Now, as I earlier told you, there is a relation between two persons. Similarly, there is in mathematics, there is a relation between the two elements. For example, if I take a practical example from our epic, that is Ramayana. So in that there was a king called Dashrath, and he had 4 sons. Suppose I make a set in which there is a family of Dashrath. Dashrath, his son was Ram. The next one was Lakshman, then Bharat, then Shatrughan. It has gone out of that box. We can change that also. That is very much feasible. So this is a set. So let us name this as A. And there is another set in which the names of their wives are written. Dashrath had 3 wives: Kaushalya, Kekai, Sumitra. Those who have read Ramayana, they might be knowing all this. Then Sita. Ramayana is a Hindu epic and very popular in India. Sita, Urmila, and Mandvi. And Shatrughan's wife's name was Shrut Kirti. So this is another set of the females, and let us name it as B. Now suppose my relation is, suppose I say was husband of. This is my relation. So Dashrath was the husband of, yes, anybody? No. Dashrath was the husband of Kekai, and Sumitra. And Ram was the husband of Sita. Lakshman was the husband of Urmila. And Bharat was the husband of Mandvi. And similarly, Shatrughan was the husband of Shrutkirti. So if I want to write the relations, that is, was husband of, elements in A, they are the males, and elements in B are the females. So how they are related? And there is one of the relations is husband. So it can be written now like this: Dashrath, Kaushalya, curly brackets over here, then Dashrath, Kekai, Dashrath, Sumitra, Ram, Sita, Lakshman, Urmila, and then Bharat, Mandvi, Shatrughan, Shrutkirti. So this was a practical example. Now in mathematics, suppose I write A, B and over here write just 1. This is set A, set B. So the Cartesian product can be A comma 1, B comma 1, right? These are the Cartesian product, that is A cross B. Now relation between A and B can be, the first relation can be, suppose I write only A comma 1. This is the first relation. Second relation can be, I can write B comma 1. Third relation can be, I can write A comma 1 comma B comma 1. And the fourth relation can be, that is there is no relation, or it is called empty relation or sometimes null relation. And it is depicted like this, phi. Phi means empty relation or null, nothing. There is no relation between the two elements. So we found that there were 4 relations, R1, R2, R3, R4 in the above example. Now how we have actually calculated? We have drawn all the relations and then counted. So we got the term 4. But if the number of elements are more, so it is very difficult to make the all relations. Let's take an example. Suppose this is A. This is A consists of 1, 2, 3, 4, 5, and there is B. Suppose it consists of A, B, C, D, E, F, like this. So in A there are 5 elements, in B there are 6 elements. How much number of ordered pair will be there? That is 5 into 6, that is 30. Now there are 30 ordered pairs in the Cartesian product, and how many relations are there? So we cannot form all the relations as we have done in the previous example. So what is the best method? Now we know that there are 30 ordered pairs. Suppose let me make few ordered pairs among them. 1 comma A, 1 comma B. Okay, let us draw all the ordered pairs. 1 comma C, 1 comma D, 1 comma E, 1 comma F. Similarly 2 comma A, 2 comma B, 2 comma C, 2 comma D, 2 comma E, 2 comma F. Third 3 comma A, 3 comma B, 3 comma C, 3 comma D, 3 comma E, 3 comma F. Similarly 4 comma A, 4 comma B, 4 comma C, 4 comma D, 4 comma E, E, 4 comma F, 5 comma A, 5 comma B, 5 comma C, 5 comma D, 5 comma E, 5 comma F. So this is the all ordered pairs in the Cartesian product. So the number of relations we were talking about. See, every ordered pair has 2 options. Either that particular ordered pair, for example 1 comma A, will be in the relations or it will not be in relations, right? Either 1 comma A will be in the relation or it will not be in the relation. So it has 2 options. So it has 2 options. 1 comma A has 2 options. Similarly 1 comma B has 2 options. So like this, suppose I say 1 comma A, let me make a tree diagram, you will be easily able to understand. So it can be there, it will not be there. Corresponding to this 1 comma B 1 comma b. The next one, it can be there, it may not be there, and 1 comma a is not there, so 1 comma b can be there, it cannot be there. So in particular in this two, if there are two ordered pairs, there are four options: 1, 2, 3, 4, and we can write like this: 1 comma a and 1 comma b. This is one relation. Second relation is 1 comma a, that's it, 1 comma b is not there, then 1 comma a is not there, so only 1 comma b, and last is 5, neither 1 comma a is there, nor 1 comma b is there. So like this there are four ordered pairs, four relations. So that was in the case if there is only 1 comma a and 1 comma b, but now there are 30 such ordered pairs. So what we will do, we will do 2 into 2 into 2, so many, 30 times, up to 30 times. So number of relation is equal to 2 power 30. And how 30 has come? 2 power 5 into 6. There were 5 elements in A and 6 elements in B. So this is the number of relation. Now we can generalize this. Suppose I write NA is equal to N and NB is equal to M. NA means the number of elements in A set is N and number of elements in B set is M. Then number of relations, or number of, first let me write number of ordered pairs. Number of ordered pairs in the Cartesian product, in the Cartesian product is equal to N into M, N into M, and therefore number of relations, each ordered pair can be there or may not be there, 2 raised to power N into M. So this is a, you can say, formula, and how it has been evolved we have just learnt that the number of relation is equal to 2 raised to the power number of elements in set A into number of elements in set B, or like this we can write 2 NA cross NB. Yeah, 2 raised to the power number of ordered pairs in the Cartesian product. So this is the way to find out number of relations. Now one more thing, there can be two relation, those are important. First relation can be empty relation, there is no relation, empty relation, and there can be another relation which is having all the ordered pairs, and that is called universal relation. Universal relation, and which is not having any elements, they are called empty relation. Now these two type of relations are named as trivial relations. So somebody can ask somewhere in the competitive exams, how many number of relations are there in the set A? How many number of relations are there in the set A? What does it mean? It means the relation between A to A, that is R relation between A to A. Suppose like this, there is A and there is A over here. So number of relations, how many number of relations are there in the set A if NA is equal to N? So the number of relations will be number of relations will be 2 की power n into n, that is 2 power n square. Now somebody may ask the number of non-empty relations in the above question, in the same question. Number of non-empty relations. There was one relation which is empty and we don't want that, to 2 power n square minus 1. Somebody can ask number of non-trivial relations, that is 2 power n square minus 2. Why minus 2? One is empty set, another is universal relation, empty relation, another is universal relation. Both have been deducted because they are trivial relations. So obviously number of trivial relations is equal to 2 power, no, is equal to 2 only, is equal to 2. So up to here we have learnt the ordered pair, Cartesian product and relations. Now we go further and we have to learn 3 main topics in relations, and that will be continued in functions also. So domain, another is range, and third one is codomain. Right? Now what is domain, range and codomain? Domain is the permissible value of your first, you can say, element in the ordered pair, or in sometimes we called it as domain are the values of x, values of x, and range is the values of y or permissible values of the second element of the ordered pair, and codomain are the all elements from where we have taken second element of the ordered pair. Now there must be some confusion कि what sir is telling is not clear to us. Now suppose I say कि relation between A to B, and A consists of suppose I write 1 2 3 4, and okay, and B consists of 1 2 3 4 5 6 7 8 like this, and 9 10. Okay, 1 2 3 4 5 6 7 8 9 10. Now the relation between A and B is such that we can write like this: R is equal to x comma y, such that y is equal to 2x and x belongs to A and x belongs to B. So that means y is twice of x. So x can, what are x? X are all the elements of A, because x represents the domain. So domain is equal to all the elements of A, that is 1 2 3 4. Similarly the range will be twice of these, so 2 into 1, that is 2, 2 into 2 4, 2 into 3 6, 2 into 4 8. And what about codomain? Codomain is all the elements of B, that is 1 2 3 4 5 6 7 8 9 10. Right? So, and the relation can be written as 1 comma 2, 2 comma 4, 3 comma 6 and 4 comma 8. right? And this when I write relation in this form, this is called roster form. Roster form means where all the ordered pairs you can see, and this type of relation, this way of writing a relation is called set builder form of relation you can write. This we had learned in chapter of sets also. Set builder form means we have to clarify what formula is being used, and in the roster form we will actually write all the ordered pairs. So the domain, as we were on this part, domain are the first elements 1 2 3 4. These are the domains. You can see 1 2 3 4, and the range is the second element, and the second element are, these are your second elements 2 4 6 8. So 2 4 6 8, these are your range. So we can, one more thing which we can learn it from here is that range is a subset of codomain, right? Subset of codomain means the range will not be greater than codomain. Either it will be less than that or it will be equal to the codomain. So I hope you have understood what I wanted to make the point regarding relations. So this much theory is there in the chapter of relation and function, 11th class CBSE syllabus I am talking about. And in next class we will be doing the relations extended one, that is which comes in the 12th class. That is what, there are different type of relations also. So we will be doing that in our next class, that is the 12th class, you can say, relations on 12th. Then we will be learning functions of 11th and then functions of 12th. Like this we will be doing, and in sometimes in the classes I will be doing few more questions. So I hope you like this my video. So please like, share and comment and motivate me to make all more such nice videos. Thank you so much. God bless you. Have a nice day.